last class, we started with the discussion of the extra questions of the chapter Matter in Our Surroundings. So we had done till one of the assertion reason. Now we have to start with another assertion reason. We are going to continue. So I'm going to give a few more assertion reason and then we are going to continue with the very short and the other type of questions. This week, we are going to finish with this chapter after doing all the extra questions. So make sure in case you have a doubt, you may ask. So yes, first assertion for today. During evaporation of liquid, the temperature of the liquid remains unaffected. Akshara and Yukta, keep your videos turned on. Reason: kinetic energy of the molecules is directly proportional to temperature. So let us discuss about the assertion. Harshit, can you tell me, will the assertion be true or false?
Ma'am, the assertion is true.
The assertion is true according to you. That during evaporation of the liquid, the temperature of the liquid remains unaffected. Jitendra, what do you think? Is it true or false?
Ma'am, it is true.
Okay. Akshara?
Ma'am, it's true.
Yukta?
Ma'am, it's true.
Sampath, what do you think of the assertion?
Ma'am, I guess it's false.
Rohit?
Ma'am,
Rohit?
false.
Okay, those who say that it could be false, can you state the reason why do you think that it should be false?
Ma'am, because during evaporation, the liquid will absorb the heat energy, so the temperature might rise also.
Guys, what is the difference between evaporation and boiling? Evaporation causes,
Cooling effect.
so the temperature will,
Decrease.
so the temperature will decrease. So that's why it's a false statement. The temperature. Okay, children, those who said true, is it clear to everyone? You have to consider all the points while you are considering any process. Next, kinetic energy of the molecules is directly proportional to temperature. Yes, Jitendra.
Ma'am, it is true.
Yes, it is true. So when the assertion is true and the reason is false, the option is C part. Let's move to the next assertion reason. Assertion. First read it very, very carefully and then only answer. At room temperature, the evaporation of liquid takes place at constant rate And then the reason is during evaporation of a liquid, the temperature of the liquid remains unaffected. So yes, Akshara, what do you think of the assertion?
Ma'am, can I think for a bit and then tell you?
It is saying that at room temperature means whatever is the temperature of the room. At this, if evaporation is taking place, it occurs at a constant rate. Rohit, what do you think?
Ma'am, is it true?
Hmm?
Ma'am, is it true?
Yes.
Ma'am,
It is-
it does not occur in a constant rate.
It does occur at a constant rate because at the room temperature, whatever factors are affecting it will affect the at the surface also. So that is why it will occur at a constant rate only, because if you are increasing the wind speed, then also it's the same thing. If you are increasing any other factor or decreasing any other factor, then also the rate of evaporation for all the molecules at the surface will remain same. Okay, so it's true. Yukta, what do you think of the reason?
Yes, ma'am. Ma'am, I think it's false.
We have already
Yes,
discussed that
ma'am, it's false.
it's false, and it will be D part because this time the assertion is true but the reason is false. Now let us come to some very short answer type question, or wait, I'll give you one or two more resources. Okay. One more assertion reason for you all. Assertion: ice floats on the surface of water. And the reason is the density of both water and ice is same. So children, what do you think? Sampath, what do you think of the assertion?
Ma'am, assertion is true.
Assertion is absolutely true. Harshit, what do you think of the reason?
Ma'am, I think the reason is false.
False. It's not the both ice and water doesn't have the same density. So it is false, and the option will be again C part. Let's see if there are any mistakes. No. Now we are jumping on to the very short answer type questions. So let's move further. They come for generally 1 mark in the paper. First question: pressure on the surface of a gas is increased. What will happen? What will happen to interparticle forces. Now they are saying that they are increasing the pressure on the surface of the gas. Then what is going to happen if we increase the pressure on the surface of the gas? Then the particles of the gases, they tend to
Ma'am, they tend to come closer.
come closer. If they tend to come closer, then the interparticle forces
Ma'am, then the force
Increase the-
increases.
Increase.
they will increase. I hope the question is clear. Okay, let's move to the next question. Next question is, what happens when a liquid is heated? Whose chance is it? Akshara. Tell me the answer.
Ma'am, it transforms into gas.
Yes. It transforms into gas. Next.
Ma'am, I have a doubt in the second question.
Yes, please ask.
Ma'am, in the question, it's not mentioned about the boiling point, right?
Then also it is going to get converted into the gas.
Okay, ma'am.
Okay. Next question. Convert the given temperatures into Kelvin scale. Given temperature to Kelvin scale. First, 100 degrees Celsius. Second, 37 degrees Celsius. Rohit, what will be the answer for the 100 degrees Celsius?
Ma'am, 373 Kelvins.
Correct. Sampath, what about 37 degrees Celsius?
Ma'am, 310 degrees Celsius, Kelvin.
Kelvin. Correct. Next question. The water taken from sea freezes at about -2 degrees Celsius and boils at about 101 degrees Celsius. Give reason for the same. Yukta. Yukta. Yukta, are you there or not? Pranav. 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 Children, if you are unable to unmute yourself, then I don't think there is any point of you being in the class. If you want to just see the recorded sessions, they are already available to you. If you do not want to unmute and interact, then what is the point to come to the class? How will I get to know which topic is not clear to you? Harshit, can you tell me the reason?
Ma'am, the reason is because of the mixtures and impurities present in the water.
Yes. So the answer for this is that due to the presence of impurities, presence of impurities, the freezing point decreases, the freezing point or the melting point decreases, and the boiling point increases. I hope this is clear. Next. Next question is, when a solid starts melting, its temperature does not rise till the complete solid has melted. Explain. Jitendra.
Ma'am, due to latent heat of fusion.
Then what happens? Where is this heat energy going? Tell me, where is this heat energy going? Akshara, where is this heat energy going? Tell me, what happens to the heat energy which we supply continuously to the solid while it is getting converted into the liquid state?
Ma'am, it remains constant.
Oh, it remains constant, but where is that heat energy being utilized? Where is that heat energy
Ma'am,
going?
it is being utilized to get converted into the kinetic energy which is used in latent heat of fusion.
The heat energy supplied, it is a very, very important question, children. You should know the answer for this question. The heat supplied is used to overcome the force of attraction between the particles. Okay. Now is it clear? You should know these few words because this is a very, very important question. It comes in multiple forms. Next, water droplets seen on the outer surface of a glass containing ice cold water is due to Sampath.
Ma'am, it's due to condensation of the water vapor.
Yes, ma'am.
It is due to the condensation. This we have, you must have written in the test yesterday. Also, I gave you the same. Yes.
Ma'am, actually, when we heat glass suddenly to high pressure, high temperature, it bursts. Why does it occur?
The glass,
Yeah, ma'am. Actually, if we keep heat on any single part, it bursts suddenly.
because it is sensitive to heat, there are different types of glass. There are certain glasses which are thick enough that they can be molded in different shapes when the heat is applied. Whereas the general glass which we have at our home, if we try to heat it, it breaks due to the weaker forces of attraction between them because it depends on the quality of the glass. Fine.
Okay, ma'am.
Yes, ma'am.
Change of gaseous state directly to solid state without going through liquid state is called. Yukta, now are you there?
Yes, ma'am, I can hear.
So it is called,
Deposition.
yes, this is known as deposition. Next question. Dash is a surface phenomenon. Pranav, are you there? Pranav? Okay. Harshit?
Ma'am, evaporation.
Right. The answer for this is evaporation. Now, next are the short answer type questions. Let's move to them. First question. Define latent heat of vaporization. Jitendra.
The amount of heat energy required to convert 1 kg of liquid into gas at atmospheric pressure
Yes, and what
at,
temperature?
at its vaporizing point.
At its boiling point. Very good. So the heat energy required to change 1 kg of liquid to gas at its boiling point is called latent heat of vaporization. Fine, children. Next question. Explain why temperature remains constant during the change of state of any substance. Yes, Rohit. What do you think of this answer, this question?
Ma'am, so that the substance doesn't overheat. That's why the temperature is constant.
Read the question carefully.
Yes, ma'am.
Who will answer this question?
Ma'am, can I?
Yes.
Ma'am, because the heat supplied is used to overcome the state of matter, the forces of attraction.
Again and again, the same question is coming in different forms. You do not know when to answer. Temperature remains constant, means the temperature is not changing. When does the temperature doesn't change? When the change of state of matter is happening. So it is again, it is due to the latent heat. The heat energy is used to overcome forces of attraction between particles. Children, it is a very, very, very important question. Listen to me very carefully. In what all forms this question may be asked, and the answer will remain the same. The first type would be that they might ask you while the solid is getting converted into the liquid state, or while the solid is melting to the liquid state, the temperature remains constant. Why? This is one form. Another form, why does the temperature remains constant during the change of state? And then here they might mention during the change of state from solid to liquid or liquid to gas. There also you have to pay attention. If it is solid to liquid, it is latent heat of fusion. If it is liquid to gas, then it is latent heat of vaporization. This question can come in multiple forms. The language will change, but the answer will remain the same. Only thing you have to remember is that during melting, the temperature doesn't change. During boiling, the temperature doesn't change. And whenever the temperature is not changing, then in that case, the reason for that is the latent heat. The latent heat is the heat energy which we supplied for the conversion. Where is the heat energy going? To overcome the force of attraction. Any doubts, anyone in this question? Because it's an extremely
No.
important.
No, ma'am.
Okay. Mohammed Rayan, are you there in the class?
Yes.
Okay, so my next question, an easy one for you. Define sublimation with true examples. Tell me. Rayan, do you know what?
Yes, yes, I know it. Sublimation is going from directly solid to gas.
Very good.
One case is in which dry ice directly turns to gas,
Correct.
and other is naphthalene balls.
Very good. So process of change of solid state directly to gas without getting converted to liquid state. Examples for these are naphthalene balls and dry ice. Only two are asked. There are many other examples which I have already given to you. Next question. Next question is now you have to think upon this. Is sublimation a surface phenomenon or a bulk phenomenon? Tell me, who can tell this answer? Think and answer.
Ma'am, it is a surface phenomenon.
How can you say that?
Ma'am,
Ma'am,
because as soon as we take out dry ice, it starts converting into vapors, but without letting a whole the particle to change from gas.
Very good. Absolutely correct definition. Yes. Any other child has any other point to say?
ma'am, we can take the naphthalene balls. It
Okay.
will take a lot of time and the surface gets converted into gas.
Only the surface doesn't it entirely get converted into the gaseous state? Slowly and gradually, doesn't it get entirely converted into the gaseous state?
Yeah, ma'am.
So it is both. Sorry. It is both surface phenomenon, exact same example as Sampath has quoted. In case of surface phenomenon, we take the example of dry ice because it happens only at the surface. Whereas in case of bulk phenomenon, we take the example of naphthalene balls, which we see that the entire naphthalene balls get sublimed with time. Clear, children? One more question I'm going to give you. You have to do it by yourself and tell me the answer right now. At what, I'm not sure if we have discussed this or not, but now I need to discuss this. At what temperature does Kelvin and Fahrenheit scale same? Solve this if you can, otherwise I will help you out. Anyone has done? Okay, do you people know the formula? Should I help you with the formula? Then you may try. Should I tell you the formula? It is degree Fahrenheit minus 32 multiplied by 5 by 9 is equals to degree Celsius. Now try. And why are your videos turned off? Yukta, Harshit, Akshara, Rayan. If we are saying that both needs to be same, the value should be same. At what point will they be same? In that case, we can consider that temperature to be X. Let the temperature be X. The temperature at which both will have the same value be X. So we are going to substitute degree Fahrenheit and degree Celsius both with X. So X minus 32 multiplied by 5 by 9 is equals to X. So when we multiply 5 by 9 inside, it becomes 5x by 9 minus 160 by 9 is equals to X. So if we take the LCM, 5x minus 160 upon 9 is equals to X. So 5x minus 160 is equals to 9x. Minus 160 is equals to 9x minus 5x. This is basic maths only. 160 is equals to 4x. X comes out to be minus 160 upon 4, which is minus 40. So at minus 40, both will have the same values. At minus 40, both are going to have the same value.
Okay, ma'am.
Is it clear?
Yeah, ma'am.
Can we move further to the next question? Okay. So the next question is, do we sweat more on a dry day or humid day? Justify your reason.
Ma'am, may I?
Yes, Sampath.
Ma'am, we sweat more on humid day, ma'am, because in humid day the moisture content in the surroundings is very high, which decreases the rate of evaporation and lets the sweat be on our body.
Very good. That's absolutely correct. So the answer is humid day, because on a humid day, the moisture content is already high. The moisture content is high, which decreases the rate of evaporation. Therefore, the sweat remains on our body itself. Is it clear? Any doubts? Okay, last question for today. List 2 properties that liquids have in common with gases? Tell me.
Ma'am, one is fluidity.
Very good.
Ma'am, other is indefinite shape.
Very good. So it is fluidity. And the next one is indefinite shape. Fine, children. Now we are going to do some more questions in our next class. Do revise the chapter in case you have any doubts in the next class. I'll first consider your doubts and then only we will go ahead with the other questions. Okay, children. Have a good day, everyone. Bye, children.
Okay, ma'am. Bye, ma'am.
Bye, everybody.